Alright, here is the video guide for lesson 1.2.2. I'm going to try to keep this one short, and so it's a little bit different than the last one. I'm really just going to be working on the problems and asking you to read the directions. If you have any questions about what the directions are asking or the bigger picture, please email me. I'm happy to break down problems individually. Just say, send an email saying like, hey, I need better understanding of 159, and I'll make a video specifically for you for 159. Alright. So again, this is lesson 122. This lesson is about rigid transformations. We already did one rigid transformation. We did reflections. Now we're going to look at rotations and translations. All right, so 159, the first one, we are going to flip this triangle over both horizontal lines, or sorry, both vertical lines of reflection, and I'm going to do that through the E tool. So they give us this E tool, and they're going to give us two triangles to try to reflect them with. And remember, I'm just going to use the counting method that I taught on Tuesday. And so point B here is 3 away, so the new B has to be 3 away on the other side. A here is 1, 2, 3, 4, 5, 6, 7, 8, 9 away, so it has to be 9 away on the other side. C here is 11 away, and so it's got to be 11 away on the other side. And we have our first reflection, just using that counting method. Okay. A here is going to be, it looks like 6 away. 1, 2, 3, 4, 5, sorry, 5 away. And so that means the new A has to be 5 away. C is 3 away, so the new C is going to be 3 away. And B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 away. And so it's going to be 11 away over here as well. And we have our reflection. Okay, take a look at that. We're going to use that in the next question, next part. So it says examine the result. So that's what I have right here. And then it says what single motion would bring you from the first triangle to the last triangle. And so if we look at it again, that's the first triangle, that's the last triangle. It looks like you could just slide it over, right? It looks like if you just took this triangle and slid it over, you would get the last one. So that's what I'm going to say. What single motion? Horizontal slide. We'll bring it over. Okay. Part C, again, read it closely. The big part here is this word translating. That slide, I called it a horizontal slide. But just that sliding over effect, where you could just take a shape and slide it, that's what we call a translation. So that's that second rigid transformation, the first one being a reflection, and then we just did this double reflection, and it introduced the idea of a translation. Okay, so another example would be what they have over here to the right. There's the original picture, there's the final picture, and it just was slid. Nothing else changed. That is a translation. So what other words could you do to describe it? You could just say move up and down. You could say sliding. You could say shifting. Anything where the image stays the same, it just looks like it was slid around. Okay. Moving on to 160, we have what if the lens. Sorry about that. We're going to move on to 160. The difference between 160 is we are going to do the same kind of thing. We're going to flip it over these two lines, but in the first one, they were two vertical lines of reflection. Here we have a vertical line of reflection and a horizontal line of reflection. Again, I'm going to do this part on Desmos. And so, same kind of thing. F is 3 away, so the new F has to be 3 away on the other side. E is 1, 2, 3, 4, 5, 6, 7, 8, 9 away, and so it's got to be 9 away on the other side. And then G is 11 away, so G is going to have to be 11 away on the other side of the new G, what they call G prime. We'll get into notation at the end. So there is my first reflection. And then we are going to need to reflect this orange one over the horizontal line. Now, remember, this is a little bit different. That's the counting method. This is going to be what I call the diagonal counting method. Since G is 2 diagonals away, that means the new G has to be 2 diagonals away. So right here. Okay. E is 1, 2, 3, 4 and a half diagonals away. So we got 1, 1/2, 1 and 1/2, 2 and 1/2, 3 and 1/2, 4 and 1/2 away right there. I kind of lost it. I'm just going to finish this reflection for time reasons. Sorry, I kind of cut myself off there trying to edit that. But really, I just finished that last rotation, so I flipped it over that diagonal line using the diagonal counting method. And what I want you to notice, and this goes with the next problem, is Amanda noticed that the reflecting lines are not parallel, and the original shape is now rotated. So it brings in that idea of rotation. So that's the two transformations we need to talk about today, was translating, which was the sliding, and now we're talking about rotating, which is what it sounds like, just turning an image. Okay, it brings up some good points here. It talks about how the center of rotation is at point P, which point P, interestingly enough, is where these lines intersect, and so that's our center or our point of rotation. And it also talks about how if you had tracing paper, you could do it. We don't have tracing paper, so we don't really have an answer to B, but what I want you to do is use this E tool and just use this slider here, because you can see what that rotation is. It rotates about that point P of intersection, and if you rotate it 90 degrees, you land on what we need to. I must have screwed up my F a little bit here. It needs to go one down, but that's what we're seeing here. If we had tracing paper and we were doing this on pencil and paper, you could rotate that tracing paper 90 degrees and you would land right on your second reflection, which is very interesting to me because we start with reflections and it introduces translations and rotations. All right, part C here. Again, I'm going to use the E tool. We need to rotate this shape 90 degrees counterclockwise about that point Q. And so we go to the Desmos calculator. Oops, sorry. I'm going to rotate it just 90 degrees. And that's really the whole thing. Not a super exciting one. That is just making that rotation of 90 degrees. You could trace that on your paper if you want. But these E-tools just show you real quickly what that rotation looks like about a point. Okay, big one here. I'm not going to read all of it, but please read it. It talks about what kind of notation we use when we are transforming these shapes and using rigid transformations, because we have the same shape, so they use the same letters, but they'll put primes at the end of the letters. They'll say A prime, B prime, D prime, C prime to denote that this is a new shape, or not a new shape, but a moved shape. A transformation has happened to it. Okay, and those are important because you'll see in this problem, those donations can tell us what transformation happened. So if you look at A, it says, look carefully at the corresponding vertices. So like A and A are corresponding. Can you rotate or reflect the original shape to make the letters correspond as shown? If you can reflect, where would the line of reflection be? Well, you can reflect it, and that line of reflection would have to be right down the middle here. That would have to be my line of reflection. And if you think about it, and some of us were pretty good with the visual aspect on Tuesday, if you reflected it over that line, then, you know, that point B is the same distance here as it is over here. Same for A, same for B, and so on. And then it says, if you could rotate it, where would the point of rotation be? Well, we kind of saw that in the first problem. That's just one reflection, and there's no horizontal reflection. There's nothing that I can say that this would be rotated to, and even if you're just a visual person, I can't really think of a way that you could rotate this so that B would land on B. And so I'm going to say that there is one line of reflection, it's this vertical one, and that there is no point of rotation. Moving on to B here, it says this has been rotated 180 degrees, and now what we need to do is label the vertices with the correct donation, I keep saying that wrong, sorry. So we just have to label it right. If this was moved 180 degrees, that means A prime is now down here. So A prime is down here. Sorry, excuse me, that's not right. A prime is over here. B prime is down here. C prime is going to be up here. And then D prime is over here. because really what happened is that shape just got flipped upside down. Got flipped 180 degrees. Okay. I believe the last problem, and then make sure we're going to take a look at these math notes and make sure you read them closely today. It gives us really good vocab. It might be even helpful for memorization reasons to write those vocabs down, but we'll get to that. So it says after what if you have the original figure and the image, what sequence of transformations? So we're going to try to think of two different ways that we can transform this so that we get the image shown. And the first one I'm going to do, I'm going to think that this could be slid down. You could slide it down 2 units, and then you could reflect it about that 3 line. And so the two transformations you could perform is a translation and then reflection. Or I should say translation and reflection because it doesn't matter the order. Okay. The second one, what we could do is a rotation. And so we could rotate this triangle so that it lands, and I'll try to draw it out a little bit. We could rotate it so that it lands here, and this is going to be sloppy because I'm doing it by hand, but you could have a triangle right here by rotating it upward, and then we could flip it downward. And so the other 2 transformations we could do would be a rotation and then and reflection, because again the order doesn't matter as long as we do it correctly. So those would be the 2. Again, please take a look at these this math notes box, and again, maybe it would help to write it down because it never hurts to have these memorized. We're going to use them throughout the rest of the chapter, and eventually we'll see it on a chapter test or quiz or formative. So make sure you write them down. And then lastly, like I said, this I went by pretty quickly. I don't want to take more time than I have to. And so if you have questions, say you want a better explanation on 161. That idea of notation didn't make much sense. All you have to do is email me saying, can I get a further explanation on 161? And I will make specific videos. All right?